Hi guys, I'd like to take a look at question number 4 of paper 1 2015. So if we look at question 4, it says f of x is equal to 2 to the power of x plus 1 minus 8. And I want you to write down the equation of the asymptote, sketch the graph, and then the graph is obtained by reflecting. So this is just a simple graphing question. It's not very long, so it shouldn't take us too long to do. So let's get started. Okay, first we write down the actual formula. So they say we've got f of x, which is equal to 2 to the power of x plus 1 minus 8. Now first, what kind of graph is this? This is an exponential. You can see because the x value is in the exponent, therefore it is an exponential. This guy over here is our vertical asymptote, horizontal asymptote, so it's our vertical shift. So normally an exponential would look, it's a positive exponential, so it would look something along the lines of this, and it will cut based on this x shift. Just to note, this one here is our x shift, but because we have a negative 8 there, we're going to have our asymptote shifting down to negative 8. Okay, so how do we go about doing this? Well, firstly we say 4.1. It says write down the equation of the asymptote. The asymptote is y equals negative 8. Okay, as I mentioned with this red line. 4.2, it says sketch the graph, clearly indicating everything. So the first thing we do is we say f at x when x is 0, and that's equal to 2 to the power of 0 plus 1 minus 8. 2 to the power of 1 is just 2, minus 8 is minus 6. So when we have x at 0, in other words, on this line here, when x is 0, we get minus 6. So it cuts at minus 6. We know the asymptote's at minus 8, it cuts at minus 6. And what about when f of x itself is 0, and we solve for x, 2x plus 1 minus 8, take the 8 across and you get 8 equals 2x plus 1. Obviously 8 is the same as saying 2 to the power of 3. 2 to the power of x plus 1. Let's go to the next page quickly. Right, and 2 to the power of 3, we can simply drop the bases because the bases are now the same. X plus 1, x equals 2. So what we have over here is when the y value is 0, in other words on that line, we get x equals 2, which makes sense because you can then see that our graph does that. So we go that way through that, and that's our graph. So I'm going to remove the previous one because that one's obviously not the same. So we can see it goes through negative 6, 2, and it's got an asymptote at 8, and that's it. Simple as that, 4 marks. 4.3 says the graph of g, let's go g of x, is obtained by reflecting the graph of f in the y-axis. So if we take that graph, we reflect it in the y-axis, that's this axis over here. We reflect that, in other words, this thing goes onto that side. So we take the page and we fold it. And what happens when we fold it in the y-axis? Well, our x swaps. So this x over here, this 2 becomes negative 2. Obviously everything else remains the same. So our graph is simply going to do that. Hopefully I hit the correct points, but our graph is going to flip. So when you flip in the y-axis, our x value becomes negative. And if we flip in the x-axis, our y value becomes negative. So this is simply equal to f where the x values are negative. So what is the equation for f? The equation for f is simply that. So we can rewrite that. So that's equal to 2, remember f of x is equal to 2 to the power of x plus 1 minus 8. And we said all the x values become negative. So we literally plug in negative every time we see an x value. So just put it in brackets, minus 8, and that's our new answer. We don't have to do much more than that. We can leave it like that. You might, if you really want to, simplify that, but there's no need. I suppose the simplest is just to drop the brackets. Negative x plus 1 minus 8. And that's your answer. Okay, that's it.